In this video, we're going to build an arpeggiator sequencer into your Werkstatt. For this project, we'll need a breadboard, a 10K resistor, a 2.2 microfarad capacitor, a Phillips head screwdriver, some jumper cables, and an Arduino microcontroller. You're also going to need a way to upload the code onto your Arduino. For today, I'll be using this laptop. First, take a Phillips head screwdriver and remove the top 4 screws on the Werkstatt. Inside the PCB, there will be screws holding the board to the chassis. These are the screws that you'll need to get ground off of. Simply strip one end of a jumper cable, wrap it around the ground screw, and tighten. So now that we have our ground out connected to this jumper, connect the jumper into your breadboard. From here, take your 2.2 microfarad capacitor and make sure that you plug the short end into ground. This is a polarized capacitor, meaning that there is a negative and positive lead. The negative lead is delineated by the shorter side of the capacitor. From there, take your 10K resistor and plug it into the positive lead of the capacitor. Now take a jumper cable and plug it into digital output 6 on the Arduino. You'll see next to the number 6 that there's a little squiggly line. This means that this output sends a pulse width modulated signal. Take that PWM output of digital 6 into the other end of the resistor. The last thing we need to do is make sure that our Werkstatt and our Arduino share the same ground. So plug another jumper cable into the ground on the Arduino and plug it in to the ground of the Werkstatt. So what we've created here is what's known as an RC low-pass filter. We're using a resistor and a capacitor to filter the signal from the pulse width modulated output. We do this because the PWM output is not a true analog signal, and for it to speak to our Werkstatt appropriately, we need to pass it through a filter. Now we can hook in to our VCO exponential in. We'll take another jumper cable and patch right where the resistor and capacitor meet, on the positive lead of the capacitor. From there, we can patch into our VCO exponential in. So now we should be ready to upload our code. The example code that comes with the library is actually a calibration code. The arpeggiator will start with the root note you play and alternate into what should be the octave. Now we're going to need to take our Phillips head screwdriver and change the VCO exponential trim, or VR5, to make sure that that octave is a true octave. So now you can hear we're getting a true octave out of our code. Now that we have the VCO exponential in calibrated to work with our Arduino, we can go into the code and change the interval values to program our arpeggiator. So initially, the arpeggiator code came programmed with the tonic or root note to the octave. I'm going to reprogram the arpeggiator to play a minor chord, ascending and then descending. So we have the tonic, we'll add in a minor third, a fifth, our octave, back down to the fifth, and end on the minor third. Now, in the code, we can actually decide how fast we want this arpeggiator to play through. This is decided in the note value section. Here you can see I'm assigning variable E, or eighth note, to each of the arpeggiator notes. Then at the bottom, when we call the arpeggiator play function, we can set the BPM, or beats per minute. Here I'll change it from the exercise 140 to a 110. Now that's a little too slow for me, so I'm going to change from eighth notes to 16th notes by using the variable SX. You'll want to make sure that you have the same number of variables in the note value array as you do in your note array. By using the Arduino and a few discrete components, we were able to create an arpeggiator sequencer for our Werkstatt. We encourage you to experiment with the code and create new patterns for your Werkstatt. All Arduino code, parts list, and fritzing models are available online at werkstattworkshop.com.